Neutron stars are strange and fascinating objects. They are born from the death of massive stars. Imagine a star much bigger than our sun, collapsing under its own gravity. The result is a neutron star, incredibly dense and small. These stellar remnants are only about the size of a city. However, they pack the mass of our sun, or even more, into that tiny space. A teaspoon of neutron star material would weigh billions of tons on Earth. Neutron stars spin rapidly, some making hundreds of rotations in a single second. They emit beams of radiation like cosmic lighthouses. When these beams sweep past Earth, we detect them as pulsars. Sometimes two neutron stars find themselves locked in a gravitational dance. They orbit each other, getting closer and closer over millions of years. Finally, they collide in a spectacular event. The collision is incredibly violent. Imagine the energy of a billion suns released in an instant. The two neutron stars merge, their matter and energy combining in a chaotic explosion. The intense gravity during the collision distorts space and time. It's like dropping a stone into a pond, creating ripples but on a cosmic scale. These ripples are called gravitational waves. The fate of the merged neutron stars depends on their combined mass. If the mass is large enough, the collision creates a black hole, an object so dense that nothing, not even light, can escape its gravity. If the combined mass is not sufficient to form a black hole, the merged object forms a heavier neutron star. This new neutron star will be even denser and hotter than the original two. It will eventually cool down and spin slower over billions of years. The collision also creates a burst of light across the electromagnetic spectrum, from gamma rays to radio waves. This burst is called a kilonova, and it can outshine entire galaxies for a brief period. The detection of gravitational waves from neutron star collisions is a major breakthrough in astronomy. It allows us to hear these events and learn about the universe in a new way. By studying these collisions, we can gain insights into the nature of gravity, the behavior of matter at extreme densities, and the origin of heavy elements like gold and platinum. These elements are scattered throughout the universe by the explosions. Neutron star collisions are rare, but they play a crucial role in the evolution of the universe. They remind us of the immense power and beauty of the cosmos.